Okay, this is a short lesson on finding the equation of a quadratic function. So remember, we can have the equation of a function in standard form. We can have it in vertex form. And we can have it in factored form. Let's just call this R and S. Okay, so those are the three ways we can write a quadratic function. So if it has roots 2 and -3, so x equals 2 and x equals -3. So if you remember, if we have it in standard form, I'm just going to erase these because we don't really need them. So if we have roots 2 and -3, so we've got 1 at 2, 1 at -3. So if we were only given the roots, we wouldn't really know exactly what it looked like. It could be concave up. It could be a little bit compressed. It could even be concave down. We don't know. So this would be considered a family of lines with roots at 2 and 3, -3. So there's lots and lots, infinite number of lines that could pass through those 2 points. The difference is they would all have different stretches. So in order to find a specific line, we also need a point that is on that line. So if we have the roots x equals 2 and I isolate and set to 0, that means that the factor would be x minus 2. I bring the 2 to the left. And if I have a root at -3, I'll bring that over. That means that the factor would be x plus 3. So what I know is that the two factors are going to be x minus 2, x plus 3, and there's going to be some stretch that I don't know. So now I have to find the value of a to make it a specific line rather than a family of lines. So since I've been given x and y, 3 goes in for the y, and -1 goes in for the x's. So I'm substituting in the point -1, 3. -1 goes in for the x, 3 goes in for the y, and we're going to solve for a. So this bracket equals -3, this bracket equals 2. So we get 3 equals -6a. So a is going to be 3 over -6, or -1/2. Once I have that stretch, I can write the equation. Let's get a little bit of room here. I'll write it up here. So the equation of this line would be y equals, So it would be y equals -1/2, that's the stretch, x minus 2, x plus 3. That is the equation of that function that passes through to -3, and we determine the stretch to be -1/2. Okay, so let's do another one down here. Find the equation of the function that passes through, has roots -2 and 3. So let's find the factors by setting to 0. So y equals some stretch, x plus 2, x minus 3. It passes through the point 2, 12. So this is a value for x and a value for y. So we'll put 12 in for y. And then we'll put 2 in for the x. So 2, -3, and we'll solve for a. So this bracket equals 4, this bracket equals -1, so 12 equals -4a. So a equals 12 divided by -4, which is -3. Once I know the stretch, we'll put it at the front. Just make sure that it determines the question whether it wants it in vertex or factored form, I should say. Let's erase that. So this is in factored form. Sometimes it asks for in standard form. In standard form, all you have to do is expand, right? So if the question wants standard form. You would expand and collect like terms. So that's not hard to do.